Another tool we'll be seeing under retail analytics is using price elasticity of demand. We will be using price elasticity of demand for price optimization and bundling the products so as to get the benefit in the demand by optimizing the price, right? We'll be understanding this concept by means of a small example which can be enhanced on real situation. In this example, we are considering two types of milk, organic milk and almond milk. Uh, as you know, if the price is reduced, the demand is expected to increase. So we have three data points in this example for both the types of milk, organic milk and almond milk. At price of rupees 80, the demand is found to be 1200 units within certain period of time. If the price is rupees 90, the demand reduces to 1000 rupees, 1000 units. And if the price is 100 rupees, demand reduces further to 850 units in a certain situation of the organic milk. Whereas as almond milk is concerned, the price is bit higher. At rupees 120, demand is observed to be 800 units. At rupees 140 price, the demand is observed to be 700 units, and at price of rupees 160, demand is observed to be 550 units. Right? So almond milk sounds to be costlier, and demand is proportionately less. Organic milk is cheaper and demand is proportionately more. Right? As the price increase in both the cases, demand falls down. We will be finding price elasticity of demand in both the cases. Price elasticity of demand is nothing but the ratio of change in quantity, change in demand divided by change in price. But we will be dividing uh, change in demand by the center point of the demand, right? And change in price by the center point of the price. Okay, very simple formula. Change in demand divided by center point of the demand, the center point of the points we are considering, and change in price divided by center point of the price, right? If this ratio is greater than 1, that means the demand increases in greater proportion than the reduction in the price or change in the price. So if this ratio, absolute value of this ratio is greater than 1, that is to say that the numerator is greater than the denominator, then the elasticity, the ratio, the points are considered to be, or the demand is considered to be elastic. And if the ratio is less than 1, then the demand is considered to be inelastic, insensitive to the changes in the price, right? So by taking this example, we will be finding price elasticity of demand in various ranges of the price for both organic milk and almond milk, and then we'll be doing the discussion on the price based upon the price elasticity of the demand. Okay, and so let's see here. Organic milk, as we had the data in the previous table, the price at price of rupees 80, demand was 1200. At price of rupees 90, demand 1000. At price of rupees 100, demand is 850. So we'll be finding what is the change in the demand, what is the difference in demand, then we'll be finding difference in price, we'll be finding center point of the demand, center point of the price, and then we will be getting the elasticity of demand. So as you observe here, the difference in price, that is the price in the for the second data point 190, the demand is 1000, and for first data point it is 1200. The difference is therefore minus 200, right? Center point of the demand, that is found by taking the average of these two demand, that is 1200 plus 1000 divided by 2, that comes out to be 1100. Then we will be finding the ratio of these two, that is change in demand divided by center point or average of demand, minus 200 divided by 1100, that comes out to be minus 0.1818, right? And for the second and third data point, right, The change in demand is 850 minus 1000, and that is minus 150. And center point of the demand will be found by taking the average of these two, 1000 plus 850 divided by 2, that comes out to be 925, and the ratio of difference in demand divided by midpoint of the demand is minus 0.1621. Same thing we will be doing for the price. Okay, so price for second data point minus price for first data point, 90 minus 80 comes out to be 10. Difference in price, DOP, comes out to be 10. Center point of the price is found by taking the average of these two, 90 and 80. 90 plus 80 divided by 2 comes out to be 85. And the ratio of difference in price divided by midpoint of price is 10 divided by 85, that comes out to be 0.1176. Now for the second and third data point, second point and third point will be finding the same. Change in price is 100 minus 90, that comes out to be 10. Average of price is coming out to be 100 plus 90 divided by 2, 95. And the ratio is 10 divided by 95.10511052. Right now we are in position to find out price elasticity of demand for first in between first and second point, second and third point. How is that found? DOD divided by MOD, that is the first value which you get in this column, that pertains to difference in demand divided by midpoint of demand divided by difference in price divided by midpoint of price, comes out to be minus 1.5454. And similar way, the same ratio comes out to be for second and third point, 0.1 minus 1.5405, right? So almost same for both the periods between 1 and 2 and 2 and 3, right? So we are finding that the demand is elastic. It is sensitive to the changes in price, right? As the price drops, demand increases in higher proportion than the drop in the price, right? So average, if we do for first, second, third period, we are getting the average arc elasticity to be minus 1.543. Okay, a minus sign doesn't signify much. You anyhow you have to take the value absolute. Okay, now same analysis we'll be doing for almond milk, right? Here are first point is 800, 120. 120 is the price, 800 is the demand for first point, then 700, 140, then 550, 160. We'll be taking the difference in the demand of first and second point, that comes out to be minus 100. Then we'll be finding the center point between 800 and 700, that comes out to be 750. We'll be taking the ratio of these two, DOD divided by MOD, midpoint of demand, that comes out to be minus 0.133. Between second and third point, the difference is 550 minus 700, again minus 150. Then we'll be finding the center point of the demand, 700 plus 550 divided by 2, that comes out to be 625. And the ratio of these two, DOD divided by MOD, midpoint of demand, comes out to be minus 0.24. Similar thing we'll be doing for price. So difference in the price, second minus 1 comes out to be 140 minus 120, that is 20. Then third and second again comes out to be 20. Midpoint of the price, first and second, by taking the average, comes out to be 130. And second and third comes out to be 150. Then the ratio of difference in price divided by midpoint of price comes out to be 0.1538 for the first range, and for second range between second data point and third data point comes out to be 0.1333. Then as we did in the upper table, the elasticity of demand for almond milk comes out to be this value, that is DOD divided by MOD divided by DOP divided by MOP, comes out to be 0.86 minus 0.8666, right? Then for second and third point, it comes out to be minus 1.8. What does this mean? as the ratio for between first and second point is less than 1, the demand is not sensitive to the changes in price. It is inelastic demand, right? And for second and third change, second and third point range, the ratio is 1.8, right? So we say that the demand is elastic between second and third point. Okay, if I take the average of this elasticity of demand, price elasticity of demand, that comes out to be minus 1.33. Overall, I can uh, conclude that slight elastic on average, but range dependent. Elasticity is price range dependent. Okay. So, which product is more sensitive? Organic milk is more price sensitive, as we see that average elasticity is coming out to be 1.543. So, more price sensitive. Price sensitive means elastic, and price insensitive means inelastic, right? Almond milk, we are finding in first range, it is coming out to be average elasticity is coming out to be 1.333, somewhat elastic overall, but mixed. Inelastic at lower price range between 120 to 140, and highly elastic at higher price range between 140 to 160. So conclusion, organic milk is overall more price sensitive than almond milk based on the data points. Now, another analysis we can do on this data which is available to us, we can decide on setting the price range based upon the revenue which we will be earning out of the demand which gets generated due to the changes in price. So as we know that at 80 rupees we are able to sell 1200, because the demand comes out to be 1200, observed to be 1200 when the price is 80. So 80 into 1200 comes out to be 96,000 rupees. For when the price is 90, demand is 1000. So sales revenue in that setup comes out to be rupees 90,000. And when the price is 100, the demand is around 850. So sales revenue in this setup 85,000. So maximum revenue is at a price of rupees 80, 96,000 is the revenue. Okay. On the other side, for almond milk at 120 rupees, there is the demand of 800, so sales revenue 96,000. At rupees 140, you are seeing the demand is 700, so sales revenue is 98,000, and at price of 160 rupees, demand is 550, significantly dropped, but the sales revenue is 88,000. So we are seeing that at the middle price, rupees 140, the the sales revenue is 98,000 maximum, right? So here we have done this analysis based upon the sales revenue. Similar analysis can be done based on the profitability. Okay, that has not been discussed here, but you can think of doing and that, right? Mm, right. So now, organic pricing strategy recommendations. Organic milk, elastic demand, uh, absolute E value greater than 1. Reducing price increases total revenue. As seen, revenue is highest at rupees 80. That is very obvious. As we go on reducing the price, demand is expected to increase, but if its increase is justifiable, then we will be reducing the price. A recommendation in this case, consider reducing the price towards rupees 80, or run a promotion to boost the revenue and possibly market share. Alert, check margins. If unit margin at rupee 80 still covers the cost and produces acceptable profit, lowering price is good. If the margins become too thin, consider targeted discount, like loyalty members, bundle with complementary items rather than across the board cuts. On the almond milk side, mixed elasticity across ranges. At lower price, it is inelastic between the lower price range between 120 to 140. Small price increase may raise the revenue. At higher prices between 140 to 160, demand is highly elastic. Raising price hurts the revenue. So within that range, you should not increase the price. That's right. Then revenue maximizes at rupees 140. So set the price around 140. as we have seen that it is absorbed best, sales revenue. A recommendation in this case is keep the price around rupees 140, monitor sales, consider targeted price promotions in specific segment, time window to stimulate additional volume if margins permit, right? Additional suggestions, test, because we have multiple alternative, at least two alternatives we have, so we can do the statistical analysis that is called as A-B experiment. A and B stands for the experiment A, experiment B, experiment 1, experiment 2. Okay. Or the pilot stores before chain wide price changes. Consider cross price elasticity, how price changes in milk affect the demand for substitutes or complements, right? By changing the price of organic milk or almond milk, how does it affect the price demand of another milk, right? Evaluate gross margin, not just revenue. If lower price increases revenue but reduces profit per unit too much, it may not be desirable. Compute contribution margin analysis. Promotion and bundles. For organic, which is elastic, bundle it with high margin items to boost the basket value. For almond, best at rupees 140, consider value packs or loyalty coupons instead of permanent price changes. So all in all, short summary goes like elasticities. Organic milk was 1.54, means elastic. Almond range dependent, 0.87 inelastic, and 1.80 elastic. Average 1.33. So mix of elastic and inelastic. More price sensitive is organic milk. Pricing strategy: lower organic milk price to rupees 80 to maximize revenue if margins allow that. um, Price almond milk near rupees 140, observed revenue peak. Use targeted promotion rather than across the board cuts. So this will make you pro in making the decision based upon price elasticity of demand. Mm, Thank you.